Exponential growth models grow without bound, like the graph of y equals ae to the kx, where a and k are positive constants. So in order for growth models to be useful in certain applications, the growth must be bounded. To do this, we transform y equals ae to the kx to y equals ae to the negative kx by multiplying k by -1 to reflect the graph about the y-axis. Then we multiply the function by -1 to obtain y equals negative ae to the negative kx, which reflects the graph about the x-axis. Finally, we shift the graph up L units to obtain y equals L minus ae to the negative kx. The graph is bounded above by the horizontal asymptote y equals L. This exponential function is called a learning curve and is commonly used in psychology to model learning new skills, for example. It is also used in marketing to model the number of customers that become familiar with a new product after it hits the market. For example, the number of customers S who become acquainted with a new product t days after it hits the market is given by the exponential model S of t equals L minus ae to the negative kt, where t is non-negative. Suppose the potential number of new customers is 5,000. This limiting factor gives the upper bound L. So S of t equals 5,000 minus ae to the negative kt. Suppose that as soon as the product reaches the market, 1,000 people have already heard of the product. This information allows us to find the value of A, since A corresponds to an initial value. Plugging this point in and solving for A gives A equals 4,000. So S of t equals 5,000 minus 4,000 e to the negative kt. Finally, the value k gives the rate that people are learning about the new product. If we're given a percentage, then we change it to a decimal and plug it in for k. Alternatively, we can find this rate if we know another point. For example, if 1,500 people are acquainted with the product by the 5th day of its release, then we can use the point 5, 1,500 to find k. We find that k equals 0.0267, or 2.67%. So the rule of correspondence for this model is S of t equals 5,000 minus 4,000 e to the negative 0.0267 t. There's another useful model called the logistic growth model that accounts for the case in which a product does not catch on as quickly at first. This model is S of t equals L divided by 1 plus ae to the negative kt. Again, t, which represents time, is non-negative. Consider the following application. Suppose S represents the number of people at work who hear about gossip t days after the gossip starts to spread. Suppose there are 50 people employed at this job, and that on the first day, 2 people have already heard the news, and after a week, 25 people have heard the news. Find the values of L, A, and K for the logistic curve. Well, since at most 50 people can hear the gossip at work, the limiting factor L is 50. Then initially, which means that t equals 0, 2 people know the gossip, which gives the point 0, 2. This information is used to find the value of A, the initial value. Plugging this in and solving for A gives A equals 24. Then 25 people knowing after a week gives the point 7, 25. Solving for k gives k equals 0.4540, or 45.4%. So the rule of correspondence is S of t equals 50 divided by 1 plus 24e to the negative 0.4540t.